Hi, in this video I'm gonna do some review from Cal1 and solve some basic problems to get prepared for Cal2. So let's begin. Which you already familiar with these formulas I already mentioned in the drill, and I want to mention here. E to the ln x equals x, and ln e to the x also equals x. E to the fx, this whole thing's prime, equals fx prime, which is here, function about x, multiply e to the fx, which is you simply copy from here. Okay, we're gonna see an example later, but for now, you should know here is a formula. We also want to remember the product rule and the quotient rule. So for the product rule is uv prime equals u prime v plus uv prime, which is simple. Quotient rule is when u divides v, the whole thing's derivative equals this side. We will see an example to show how to apply the quotient rule. Here it is. Derivative of the x squared plus 1 over x squared minus 4. Okay, so I started from the denominator, v squared, which is the x squared minus 4 squared. On the top is u prime v, which is x squared plus 1 prime multiply the x squared minus 4, and then minus uv prime x squared plus 1 by x squared minus 4 prime equals x squared minus 4 squared 2x x squared minus 4 minus x squared plus 1 2x. This equals 2x cubed minus 8x. Pay attention to this negative sign, so it's negative 2x cubed minus 2x. So here is still x squared minus 4 squared. These two cancel out, equals negative 10x over x squared minus 4 squared. Okay, so this is how we use the quotient rule. Okay, when we solve for integrals, we want to remember these two. So if I find there are two functions about x, I can simply split it into two integrals, which is integral fx dx plus minus integral of the gx dx. Also, if I find k is a constant, I can take the k out. So k multiply the integral fx dx. Let's see an example. So if I say 3x plus 2x squared dx, these two are all functions about x, so I separate it into integral of the 3x dx plus integral 2x squared dx. And then 3 multiply 1/2 x squared plus 2 by 1/3 x cubed plus c, right? So I can solve it easily. But however, if I see this 3x plus y dx, I probably can write into this. So this part is same as here, 3 multiply 1/2 x squared, right? Plus, let's see here. I still want to solve for x because the d determines who is my variable. Here is x. So I treat y as a constant. For example, if I solve the integral of the 6 dx, I know it goes to 6x. Because this can go back, right? 6x prime is 6. Same here. Y could be whatever, 6, 5, 1/2, 2/3. So constant. So this equals xy. So if you go back, it's just y plus c. So we have to be very careful about the variable here. What we want to solve is the variable follows d. All other letters, we only treat them as a constant. Okay. Also, when we use substitution, working on a definite integral, we have to pay attention to the limit. Because when you use substitution, your limit can be changed. We will see problems later, but for now, we simply remember if I use substitution, I probably need to change the limit. Okay. So let's see some problems. Derivative of the sine 2x. This one equals cosine 2x chain rule 2x derivative. So equals 2 cosine 2x here. So the formula oopsie. So remember the e to the fx prime equals the derivative of the fx multiply e to the fx, which is here. So in this problem, the fx is simply negative x squared, right? The function about x multiply e to the fx, which is negative x squared prime. So negative 2x multiply e to the negative x squared. This is the derivative of the fx. Okay. We remember that natural log x derivative equals 1 over x dx. So here is same thing. X plus 1 square divided by 1 chain rule. So x plus 1 square, which is here, prime. We want to solve this. Okay. Equals 2 x plus 1 divide x plus 1 square, right? And I also want to solve the x plus 1's prime, right? Because of the chain rule. So here is 1, simply 1, so I can rewrite it into multiply 1 by 1, right? So these two can be cancelled out, which is 2 divide x plus 1. Okay. Here I'm gonna use integral of the fx plus minus gx dx equals integral fx dx plus minus integral gx dx. So equals integral x squared dx minus x dx minus 1 dx. So here 1 actually I could rewrite into x to the zeros, which is still a function about x, but I could also rewrite into 1. So this equals 1/3 x cubed minus 1/2 x squared minus x plus c. Okay, for this one, I noticed the highest power on x is 3, and the smallest one is 2, which is, if I think in this way, derivative of the x cubed minus 3 is 3x squared dx, which exactly gives me this part, right? X squared dx. So I know probably I need to use substitution. So u equals the whole part here, x cubed minus 3. Du gonna be 3x squared dx. So based on this, x squared dx equals 1/3 du, right? Plug in equals, so u to the 14th, which is here, multiply x squared dx 1/3 du. So I take this 1/3 out, which is 1/3 u to the 14th du equals 1/3 1/15 u to the 15th plus c. So 1/45, which is here. I want to plug this u back. X cubed minus 3 to the 15th plus c. Okay. Integral of the tangent x. This one is very important, and it's a typical question. So I want to rewrite it into sin x over cosine x dx. So notice that here is a sin x dx. See, derivative of the cosine x is negative sin x dx, which is exactly here. So okay, I set u equals cosine x, then du gonna be negative sin x dx, which is sin x dx equals negative du. Plug in, which is 1/u negative du. Yes, so I take the negative 1 out, which is negative 1, multiply 1/u du. Negative. This part is natural log absolute value u. You never want to forget this absolute value, plus c. So plug u back, cosine x, which is negative ln absolute value cosine x plus c. Okay? So we want to remember I rewrite it into sine over cosine. Again, I see sine and cosine come together. So here is dx, cosine x dx. So if I say sine x prime, it's going to be cosine x dx, which is here. So in this problem, u equals sine x, du is cosine x dx. So plug in u squared minus u minus 1 du, right? Cosine x dx, which is 1/3 u cubed minus 1/2 u squared minus u plus c. So this part actually is u squared du minus integral u du minus 1 du, right? So plug back u, which is 1/3 sine x cubed minus 1/2 sine x squared minus sine x plus c. This is the definite integral. So as long as I see the limit, I want to solve the integral first and then plug in the numbers, so I won't mess up the problem. Okay, so for this one, this is very simple, but I picked this one is because we want to know how to plug in numbers. Okay, let's see. This one is 1/3 x cubed minus x from 3 to 0. It's still easy because you want to plug 3 and plug 0 in. But later, the problem's gonna be more complicated. You may see infinity and negative infinity here. But the rule is always the same. We plug the bigger number first into the whole function, and then minus, plug in the smaller number to the whole function. So here gonna be 1/3 3 to the cube minus 3, and plug in 3 to every x minus 1/3 0 cube minus 0. So actually this goes to 0. This is 1/3 multiplied 27 minus 3, which is 6. Okay. Again, I find the highest power on x is actually 1. And for this is x to the zeros. So if I say 3x minus 2, I treat this as a whole thing. So the prime of it gonna be 3 dx, which I find dx. Okay, so I know I'm gonna use substitution again. U equals 3x minus 2. Du is 3 dx. 3 dx. Dx is simply 1/3 du. So I plug in 1 over u, which is here, equals u, by 1/3 du. Take the constant out, 1/3. So here, again, 1/3 natural log absolute value of u plus c, which is 1/3 3x minus 2 plus c. I plug this back into u. Okay. For this one, I want to rewrite it into 1 over x multiply 1 over ln x dx. So this is clear. I see natural log x, and I know the derivative of it is 1 over x dx. So which is here? If I set u equals natural log x, du is 1 over x dx. So I can match things up, this one with this one. Plug in 1 over u du, which is again natural log absolute value u plus c, which is natural log ln x plus c. You don't need to simplify, this is fine. So here I see ln x and the 1 over x again. Ln x multiply 1 over x dx. Same thing. U equals natural log x. Du is simply 1 over x dx. Plug in u du, which is 1/2 x, 1/2 u squared plus c. As long as I'm getting rid of this integral sign, I have to plus c. Don't forget this. So 1/2 ln x squared, right? Plus c. Okay, so basically for review part, I wish you could be familiar with the formulas at the beginning and know how to use substitutions to do integrals. When you see ln x, you want to find the relationship between ln x and 1 over x dx, which is u equals ln x, du is 1 over x dx. So this is how you do substitution. And also, I wish you to be very familiar with this problem, integral of the tangent x dx, which is gonna be used later as well. So chain rule, quotient rule, and basic formulas, I think we should be fine and ready for